All right, so this objective deals with the relationship between temperature and volume and density and volume. We're going to start with temperature and volume. So if we look at these pictures right here, we have a solid, liquid, and gas. And as we increase the temperature and we're looking at that, what we can see now is the particles within those different types of matter become more and more spread out or less compact. So the matter that we have, the amount is the same. It's just the space in which it takes up. So when we increase the temperature, you can see as we go from a solid to a liquid to a gas, it creates more space. Okay, it takes up more space. So the volume actually increases. Now, we can only see this if we zoom it in, but in real life, we have to do something like the balloon demo or the can crush in order to actually see what's happening here. So what we did with the balloon demo is we took a hot plate, and I know this isn't the best picture of what we did, but it's the same idea. And the air and the water inside was boiling. And what happened is when we put the balloon on there, the molecules inside only had one place to go. They wanted to spread out, so they were going to push on this balloon. And that's what they did. They inflated the balloon because they wanted to get farther and farther apart. Now, when we brought it over here and put it in the ice bath, the balloon started to deflate. The reason why, the volume wanted to become, or the molecules wanted to become more and more compact. And actually, most of you saw that the balloon actually inflated on the inside. Again, it sucked it in because that volume was decreasing so rapidly and so much compared to what it was doing. Now, if we look at the graph for a volume versus temperature graph, we're going to see a positive slope. This is because there's a direct relationship, because when temperature increases, so does the volume, or vice versa. And so we would see this positive slope depicted for it. Now, density is a little bit different when we're talking about the relationship, because there's two different ways that we can actually talk about this. And it's not hard. It's just a matter of you could kind of reasoning your way through. So density is the compactness of particles. So if we look at solid, liquid, and gases, it's obvious that solids are more compact, okay? There's more of them in a given space. Now, the amount of them is the exact same, but if we just look at an area here, there's more in this little spot than there is in this little spot, than there is in like this little spot. Okay, so when we talk about density, as we increase the temperature, as we go to the right here, the density actually decreases because the particles are more spread out. Okay, they're not so concentrated in a given spot. Now, for those math people, they like looking at the equation. So density equals mass divided by volume. And you probably heard me say density equals love. And we've split the heart up. We get an M on the top and a V on the bottom. Now, what we can look at here is we can look at an example. So let's do an just original example. Let's just say I have original density of 1 gram, because 1 is easy. So some substance that is 1 gram and takes up 2 milliliters of volume. Now, what is going to happen is I'm going to increase the temperature. Now, when I increase the temperature, my mass still stays the same. I don't add or subtract mass, but the space that the mass takes up, if I'm increasing the temperature, gets larger. So what we can see here mathematically is my original density is 1/2 grams per milliliter, and my new density after I increase the temperature is 1/4 grams per milliliter. Because my volume increases, that causes my density to decrease because the volume is in the denominator of my equation there. So what we can do here is we can take a look at the graph. The graph is now an inverse relationship, so we're going to see a negative slope, because when temperature increases, the density decreases, and vice versa. When the temperature decreases, the density will increase. And what we can do is we can look at different examples, but let's take a look, first at the exception to the rule. So what should happen is on the right, if you have liquid anything and you put the solid form in it, so like for example here, if I have liquid aluminum and I put solid aluminum inside, the solid is going to sink to the bottom. The reason why? Solid have more compact particles because the temperature is lower. But with water, it's different. Actually, ice floats, and ice when we decrease the temperature so when we're talking about ice water and we're talking about 0 degrees, the density of water at 0 degrees is higher than the density of ice at 0 degrees, which is why the ice floats, and that shouldn't happen. Ice should be more compact, should sink to the bottom, but it doesn't. That is a huge exception to the rule. Everything else should behave in the manner that we see over to the right. Now, here are some examples that we're talking about that have these relationships. Deflategate. A couple years ago, on the road to the Super Bowl, Tom Brady and the New England Patriots were accused of deflating balls. And they had the argument, well, we inflated them inside, we brought them outside, it was really cold, so they had to have deflated. And you had the opportunity to voice your opinion on what you thought was going on with the Deflategate. Now, other things that we would see is tire pressure. Typically, your tire pressure drops in the winter, so you have to add more volume in order to keep the appropriate tire pressure. And then something that you can try is a balloon in the freezer. So if you stick a blown up balloon in the freezer for a couple minutes and then you pull it out, you're going to see that the balloon is going to be all shriveled up. Again, the reason being the temperature decreases, so my volume is going to decrease, which causes the balloon to decrease. And then the last one, if you haven't done the can crush, I really suggest that you do it. It's super fun. Also, you can look up YouTube clips of it. I can't remember. I think it was Mythbusters did something with the tanker truck, and others have done stuff with like a big steel drum, which we aren't able to do with what we have here in the class. But all of those talk about the relationship between temperature, volume, and density. So if you have questions, please let me know. But that is the kind of, in a nutshell, what the relationship is. And that is what you will be assessed on. Good luck.